Thank you. Hello, everybody. Welcome to this first day of SICT. So the theme of today revolves around one question, which is, in between academia and research, in between academia and industry, how can we reimagine the road ahead? Okay, so today we'll bring together experts from the industry to investigate the strategies that they have adopted to address environmental and social issues in their operations. And we will connect it to research concerns using a multidisciplinary approach. And in brief, today we'll hear about three representatives from the industry. We'll hear from VOCSens, an upcoming local company, Google, another young local startup, and Whole Grain Digital. Then we will go back to academic speakers and we will have a nice debate. And first and foremost is Thomas Walewyns from VOCSens. So Thomas is a young entrepreneur from Belgium. He got his Ph.D. here from UCLouvain. And he's the CEO and co-founder of VOCSens, a company which is a spin-off from the UCLouvain, which focuses on the development of ultra-low power smart microsensor for environmental monitoring and industrial control applications. So, Thomas, the floor is yours.
Thank you for this very nice introduction. Hello, everyone. Good morning. Yes, so today I choose to entitle my talk Responsibility and Sustainability regarding highly reliable and qualified environmental data supply. Is it antagonist or reconcilable? So, in a few words, so first, thank you for the introduction. So indeed, I am a former PhD student from UCLouvain. Just have a problem here with my computer. Can you see the slide? I have a problem to change them. Okay, perfect. So I'm a former PhD student from the UCLouvain, and then I actually wanted to work in the valorization of the research performed at UCLouvain in the field of the environmental sensors, and especially the gas sensor. So I started that in 2016, actually, and then I see all the challenges to work from just taking academic research and then work into the commercialization, but especially also the production of the sensors to be commercialized, put on the market. But then, basically, I guess that all of you know the current problem. That's according to WHO, there are 7 million deaths a year due to the direct or an indirect cause of indoor and outdoor pollution in the world. So of course there is an impact on the health and the environment, but on many topics, from the industries, the transport, the agricultures, the building, etc. And so the means of struggle are, of course, we have emission standards, we have pollution standards to respect, we have prevention, we can do active wrestling. We have also issue with some process that we have to better control. And so there are quite many systems. We talk about the Internet of Things, the Industry 4.0, what we call also the Industrial Internet of Things. So of course it's a lot of word, and it's also a lot of sensors for better control. It's not so often good to have more and more sensors, more and more data. If we look to the sustainability of this device, but we need them for better air quality monitoring, in order to determine polluted areas, for safety improvement, etc. And so the first need, the first requirement is to know and control our environment. That's in the In the chemical, petrochemical industries, it's in the smart cities. You have a view of a polluted Paris. It's also for process control, for example, in wastewater treatment plants, in landfill sites, near, for example, paper tree or a sugar factory, for example. You can also have monitoring in animal farms, so for example, piggery or poultry farms, where you have ammonia emission from the animals, but then there is a direct link to HVAC. If you have too high ventilation, you can kill the animals because it will be too cold in the farm, in the building. But at the contrary, if you have no ventilation, you will have ammonia emission, and this gas will kill the animal also. So the HVAC problem, you will also find that in the indoor air quality, of course. Now with the COVID, it's another problem. We install everywhere carbon dioxide sensors, but it's still quite expensive. It costs about €100 for carbon dioxide sensors. But even it gives you just an idea of the problem, because when we place carbon dioxide sensors for the COVID, it's just a mean to approximate if we have changed to get COVID or not. And so what we need, what the industry needs, what the people need is to, it's to generate qualified environmental data. And when you build the sensors, basically, it's the first thing that you have to think is how to generate this qualified data. So about VOCSens, in a few words, so our mission is basically to ensure the safety and health of our ecosystems by delivering autonomous sensing solutions, supplying this highly qualified and reliable data in order to optimize the environmental monitoring and the process efficiency. And behind that, our value, and that will be all during all this talk is first what I will call the responsibility. Not only the sustainability, but a concept which we think that it's higher. It's the responsibility, because you will see, depending on the need, the requirements of an industry, even if the industries will emit polluted gases, pollutant gases, or for example, if this industry will also, for example, not respect all the constraints that we have, this industry will have to change. But first, we need to be responsible to its requirements and needs and answer the first problem, the first issue, by giving them the opportunity to better control its field, its environment. The second one is the creativity, which is really important here to get new kind of devices, and then the patient here to develop novel things, novel sensors. So if we look in the IoT industry 4.0 from technology fundamentals, what we have actually, and this especially for the environmental and gas sensors field, it's first the autonomy. When you have a gas sensors, first you need to do calibration and maintenance. That's a problem, because if you look at application with a lifetime of more than 10 years, you cannot anymore actually do maintenance each 6 months or each year, because it will cost for a technician, and it's not efficient if you want also more sensors to get a better insight about your industry, your operational site. The autonomy is, of course, also in terms of energy power consumption, because, of course, you will not be able to change the battery each year, each 2 years, 5 years. So you need to look to energy harvesting-based solution also in this mindset. The second thing, so it's the selectivity, specificity to the target gases, the target parameters, which is of interest for your customers. For example, if you need to monitor the carbon dioxide, you don't want to have cross-effect, cross-sensitivity effect of other gases, like, for example, some VOC, specific volatile organic compounds, or if you have a plant, a chemical plant where you have ammonia emission, you don't want to have cross-sensitivity to nitrogen dioxide, which is related to the pollution in your area. So that's very important. The second thing is the miniaturization, which is also in parallel with the cost, but also more with a more integrable systems. So you need systems that are like, say, plug and play, and that's easy to integrate. And so for that, basically, so there are the main thing, the main stuff to here have is basically this data acquisition and then the treatment behind in order to get this highly qualified data. And so that's what we are doing. I will not enter into the detail of the sensor chain, but basically a sensor is really complex because you start from a sensing element. It's basically what we call a transducers, which will take your chemical, your physical chemical species, parameters, and transform it into a first electrical signal. But then you have to condition it. And so you will use an interface circuit in order to transform this first electrical signal, a resistance, a capacitance, just a current, into a digital information or a frequency. And then we will treat it first locally, but also it consumes to do treatment locally, and then so we basically communicate either wirely or wirelessly the data, and then you will have many systems to either store this in a memory or do post-processing, do the visualization part, depending on the final application. And you have many companies working on each field. Actually, what we see also, it's more and more company do both development on the transducer, the sensing element, which is also often called sensors, and also on the signal conditioning processing. At VOCSens, we think that we have to think broadly and also to include post-processing of the data, because when a sensor will age, will drift over year, so to avoid maintenance, and to have remote maintenance, we need to do post-processing and then work also basically on the data, doing machine learning and defining algorithms in order to correct the drift and all the problems that we can face with the sensors in order to focus on this useful data supply for the company. And so we will mix actually both cloud, embedded softwares, API, in order to get a full solution. If we look also on the market key success factor that I defined earlier, so we have the autonomy, the selectivity, specificity, and the miniaturization in order to get this qualified and reliable data. What we developed at VOCSens is first, we use the know-how, the very large know-how of UCLouvain in ultra-low-power IC electronics. We put that all together with our own microfabrication process in order to be able to design gas sensors directly on silicon wafers by defining a multi-pixel nanotech-based process, which is fully compatible with the semiconductor industry. So thanks to that, and to also some algorithms for data processing, we can reach this selectivity, this autonomy, and putting all together also, thanks to large-scale manufacturing, we can miniaturize also the device with cost, which is efficient for the market. So we develop many things. So actually, first things is the first product in order to actually see the requirement of the market. And actually, we first not develop a pure semiconductor systems, but we put all together many sensing elements in order actually to be able to compute the relevant information for the customer. So that's basically what we have done. And thanks to that, we have a first module, which is multi-gas, multi-technology, which is interoperable. We can already actually put an highlight or concept on environmental camera. We have, instead of having a classical camera with many pixels sensitive to light, here we have less pixels, of course, but which are sensitive to specific gases or gases family, and then we can compute the environment, so making the invisible visible by being able to measure the molecule that we cannot see. So that's basically our target here, and being also multi-protocol in terms of communication. So we embed there also LoRa and Bluetooth radios in order to directly be able to put this on the field. And so you have here some example of application that's actually some historical data about ozone nitrogen monitoring, about here the pollution in the summer 2 years ago. We see that this summer was hotter than this year because we had some ozone peak. Actually, this summer we get no ozone peak. It's good for the pollution. It's good for the people going running. Yeah, it's less nice for people enjoying their summer. And here we have also another example, more based on process control. So here we place the sensors near a sugar refinery. We place the sensors separated by about 500 meters, 2 kilometers away each. So in a triangle, two in the base, so in the south, separated by 500 meters, one in the north, 2 kilometers away. And what we observe is that we observe directly that all the sensors get the same first response, which is basically due to the atmospheric condition change. So what I call the environmental noise, which is basically the difference of temperature, humidity, which are not compensated here. So you can see that it's the same everywhere. Everywhere in the same area of a few kilometers square. And here you see also at the end that when they restarted the installation of a settling point, so which smell when you go to near a sugar refinery, for example, in France, it smells a lot. And so we can measure this because it's basically hydrogen sulfide, and it's mainly a problem of process. And so I talk about our main core technology, which is here CMOS NV, allowing us to develop this multi-pixel CMOS gas and environmental microsensors by integrating nanomaterials. I will not go into details also here, it's not the goal. We are really doing, we try to actually bring the gap between the chemistry, the chemistry of the sensing materials and the electronics, which is not always easy because the chemist didn't think about the electronics integration and not at all about the software integration behind. And also the electronics engineers didn't talk with the chemist, so it's often a problem because each party didn't develop what is really important for the other one. And so we try to put everyone all together here in order to have this approach of pricing, size, and energy disruption with here several kinds of development. You see here our first some prototypes with 9 pixels, but we have the new one in production now with a 16 pixel, and then we go up to 64. You have here an example of technology comparison. When we talk about gas sensors, you have many technologies. What is important here is that we have first in dark, we have an ion mobility spectrometer, which is the reference, which costs about a few hundred euro. It's even for someone 250,000 euros, so it's a small house. It's a very expensive lab instrument. Then we have electrochemical sensors, with a production cost of about 5 euro. Electrochemical sensors is the main sensors used for in the industry, for example, with the system of companies like Dweiger, M.Sc Safety, and all these kind of companies. And actually, we also compare with all CMOS and V technology, and what you can see is that we follow quite very well, especially at low concentration and high concentration. We follow quite well the reference where the electrochemical one are saturating or have a lower detection threshold. There are also more noise, but the noise can also be reduced if required. And so you see here our way of developing, and of course also once you start from a multi-sensors module on a PCB, if you analyze your environmental impact, and then you change to a semiconductor solution, that's also a different. There is also a difference in terms of life cycle and so on. But then, in order to go more into the challenge here for the last five minutes of the presentation.
Thomas, il faudrait que tu conclues rapidement.
So how to think between sustainability and responsibility. Of course, I explained that we have to follow the HSEQ requirement, the process needs. We need autonomy. But the industry have a major reluctance to change, especially in the petrochemical industry, the oil and gas. It means that they will prefer always or often a wire power supply system than a battery power supply, and even more an energy harvesting system. And also about the wired communication are preferred to the wireless communication. And so the sustainable development is led by industry, by public administration, by people, politics. But there is a difference with the sustainability, which is for the property, the quality of a product or service to serve the sustainable development. And that's really important also to have this difference. I read a few days ago an article from LECO in June this year. So LECO is maybe not the best journal to talk about sustainability, but actually it's a very nice one. I will share with you the reference because it explains this kind of things. And also I want that just to show you also that when you need precision in the sensors, you will consume energy because you will need to do acquisition, averaging, and stuff like that. And that's just an example here that we have with our ammonia microsensors, depending on the acquisition that we need to average in order to compute a gas concentration data. You see that, of course, there is a direct impact on the energy that we'll consume also to get this precision. And of course, once we reach, for example, here about 25 ppb, there is a problem.
20 secondes
and so,
doit rester dans le planning.
That's the end of my talk. So the responsibility, we have a responsibility to offer sustainable devices for the future, taking care of people or planet, but we need also to answer to the safety and health standards of or requirement of our customers. So thank you very much for your attention, and I will be presenting.
Thank you, Thomas.